So it was okay, thank you. Okay, here is another example, again, that I like a lot, empty when full. So we all understand what's going on here, but even if we look at Google Translate, it's not the Gemini, the last version of Gemini, but really, but the Bard's part. So here, if I use Google Translate, it says in Hebrew, which means it is empty while it is being full. Okay, which is again, this is what it says, but we know the context. It's not, but even LLMs they fall short on that. And now I have this example of something that I heard yesterday, and I will ask you to really think about it. Don't be too shocked, and think if it's offensive or not, on what level or how offensive it is. So again, I heard that yesterday. There it is. Okay, so offensive, not offensive, how you're quiet, you didn't laugh. you were laughing at Groucho Marx, okay, but you're not laughing at that. So to be honest, I thought it's pretty funny, okay, but why you didn't, right? So this is the main thing I think about language in general, and definitely about machines. So let's see what Google, this is Gemini, thinks about it. So is the following joke offensive? Yes. Why? The joke is offensive for several reasons. It says one reason. It relies on harmful stereotypes. What stereotypes? I don't know. So I asked, and it says the. By the way, that's the default version of Gemini now. When you change, I must say, like, it's a bit unfair. When you change it to the Gemini 1.5 Pro and remove all the safeguards, it does give better outputs. Okay, so it really depends on the model, but we don't know exactly why and how. And if we do the same thing with the GPT, so again, it gives you all the results. Yes, it is offensive for stereotyping and sensitivity, historical context, polarizing topic, linguistic play on the word, which I think is pretty nice. The jokes that was shared, by the way, was the juice, not like juice spelled this, it's spelled the standard way. I changed it in order to see if it gets the phonetic play, and it does get sometimes. But the thing is, and what's missing is that, again, I don't find it offensive. But I don't find it offensive because I'm Jewish, and the person who shared the joke was Jewish. And it would be very different if someone else would be sharing this joke, or if I was not the audience, right? So when we talk about all of the things, it depends on context, and it really depends on context. Okay, so again, when this famous line was mentioned, and everyone was shocked. So again, it depends on context, and saying it depends on context, but it is. It does depend on context, because that's how language works, and this is how we work. Okay, so but if you go back to NLP, so the two trends of the past year and a bit, right? There are people, again, if you are into large language models, so everyone is talking about grounding and multimodality. Okay, and talking about alignment and reinforcement learning with human feedback, which is the RLHF is a methodology. It's a method basically, but it is used for alignment, basically, right? We use reinforcement learning with the human in the loop there in order to control the algorithm, right? To control the LLM and make it more sensitive to cultural norms. But it doesn't really work that well. Right? If you play with it and you check, it doesn't really work that well. Grounding and multimodality, two trends or buzzwords that relate to the way we train from the main element of the GPT-4 text, etc., etc. Also, if you go to Gemini, they don't. Is it related to me somehow? Like I'm doing something wrong? So just to give like the very quick definition, so modality means the different types of inputs, okay? Grounding in the ML context means linking or aligning different modalities, saying, okay, this image and this text are related, this text and this code, piece of code are related. And multimodal learning is to use, to learn them in a combined way, okay? So you don't use only the text or only the image, for example. You learn, you train a model on both of them, you do it together, and it's boosts performance, and it gets sort of understanding, and I would say understanding is close. And also it helps alignment because now the models kind of know better, okay, what the language is referring to, okay? It's like, think about how we teach kids, right, language. So when babies, infants, we don't give them linguistic classes, but we point at stuff. This is a chair, this is a table, and this is how we connect nouns to the objects, for example. This is what the multimodal frameworks are doing. Now, the thing is that alignment and reinforcement learning would be okay. So it is very important. Again, it improves all the models. Everyone is doing it. So just show 2 examples. But it's really hard. It's very costly to do that because you need a lot of human efforts, like for a lot of conversation in order to have even remotely decent results. Okay. And when everyone is doing it, they hire people, but the whole process is opaque. Like, how does it work? What is the task exactly? What is expected from the people? What's going on? And because of all these things that it's hard and costly and opaque, you get, again, sometimes strange results. If you remember, there was something a few months ago when people asked for European scientists, right? They portrayed it in strange ways, like people from India, etc. And the model specifically said we asked for a 17th century European scientist, expecting something like Leibniz. Okay, and the model like overcorrects itself again because of this strange way that again, everything is with good intentions, right? In order to have the model more sensitive, right, as we saw in the joke, when it gives you all the explanation, which some of it, I don't know if you managed to read it all, some of it was made up. It was not, the titles were okay, but the explanation, like the detailed explanation was a bit of hallucination in some of the cases. So this is a big issue. Okay, so here is a quote that I really love. I heard it from Jurafsky from Stanford. It says the common misconception is that language has primarily to do with words and what they mean. It doesn't. It has to do primarily with people and what they mean, which is, again, I think it's an amazing quote. The funny thing, no one really checks where this quote is coming from. Okay, so after using it for years, I did check for the paper, and I read the paper. The paper is from business school, and it's about how to manipulate people when you doing polls, right, to get the answers and the results you want. Okay, so it has nothing to do, it has to do with linguistics and cognition and everything, but the field of research here is a bit far. But nonetheless, this is, if I need to say what interests me in language in general and what I do, is basically this type of quote. And unfortunately, when we talk about all these LLMs, so they are aligned and there is multimodality and everything, but they do not address people, they do not care about people the way they are designed. And if they are, like with the reinforcement learning with humans, it's only a sort of, I don't know, like some safety measure in order not to offend anyone. But it does not really understand or geared or trained in a way to get the social context, right? The people that are using the language, the speaker and the audience. And this is what I think, very important. And this is the context. So when I say it depends on context, it really depends on the context. And the context is this relationship between the user or the speaker and the listener, which form a community in some sort of social structure that it's just hidden. You all know that as a social structure, one very straightforward way to look at it is as a network structure, and then we have our algorithms, and we have the theory and experience of how to work with that. Okay, so now I'm going to go back to theory for one slide, and I will say, okay, so when we want to address the social context with the NLP, so we have to go back to some theory from communication, from linguistics, from philosophy, from sociology, from political science. So we have the theory of face by Goffman, pragmatics, and the dialogism, which comes from literature. I put the names of the ones that I really like and use in my work, but obviously about communication grounding, I'll talk about it in a second, theory of mind, etc., because all these things or all these concepts provide the context that is needed. Now, we do understand we have the language, right, the text, and we understand what is the context sometimes, where we have a broad understanding of the context, but we're not sure how to combine them in a good enough way. Okay, so what I'm going to do now, I'm going to talk about 3 different cases or scenarios that relate to 3 different data sets. And the settings are very different, but they all benefit from the use of social context with the text. For the first 2, I will just have 1 or 2 slides, and then I will talk about the 3rd use case, which I think is, again, cooler and is more approachable if you don't do multimodal learning and stuff, even though the model there is more naive. Okay. We'll talk about that at the end if there is time. Okay, so we have the text user community. So some of the works we do, again, I call it the good, the bad, and the ugly. So we have some works about hate speech to show how the network, the community structure, how it helps identify and detecting hate speech, but also detecting hate mongers and understand how trends evolve, etc. We have another line of works about discourse in small groups, not small groups means up to a few dozens of people, right? The hate speech, we talk about people online in general, and communities that would be thousands of people. The other line of work, we talk about like contentious debates and discussion between relatively small groups of people. And again, we have some first steps. I will show one sketch of the algorithm that we use. Another interesting thing is that in this work, we show that actually in deliberation, multi-participant deliberation, it's using only the network structure that evolved. Like you look at the conversation and discussion as a network. And then you could apply really some theoretical approaches of variation of the mean cut max flow, etc. And it actually captures stance of the speakers in a really nice way, in a very cheap and efficient way. And it happens even for complex discussions. And it's not just turn taking and the stance are opposite to each other. So this is without its language, I call it language processing without any language processing actually. And there is another work that you don't see it, which is just fitting because it is under review, which is kind of taking this idea and build it and use it in a multimodal framework. And again, it improves the results and there is nice analysis of what happens and why. What I'm going to talk about today most of the time, which means from more slides until the end, are these 2 works. One from www 2 years ago, and one going to be presented in ICWSM. So if you go to Buffalo, you could speak with Abraham, which is the author. He just graduated with his postdoc in Michigan. Now, so first hate speech. So some very basic results and interesting results. Again, this is from 2 years ago. Then we took all the state-of-the-art models for hate speech detection, and we applied them on different data sets, on Gab, on Parler, which are fringe networks that are more extreme than Twitter. We also applied it on Twitter, and we see that it doesn't transfer well. And then we did fine-tuning and transfer learning, and again, it doesn't transfer well because, again, the social context is very different. So if you just look at the language, the algorithms are not robust enough and not general enough. So that's the one thing. Again, this is from a paper that was supposed to be under review, but hopefully it will be a week or two from now, which now it's a mandatory thing to use the LLMs and not only the BERT style classifiers. And again, there are different examples here. Some of them more clear than others, targeting different communities, I would say. And again, GPT-4 and Gemini are 1.5 Pro. Some of them, like the first one, it was very easy for them to detect. The other statements, again, all from social media, right? So they do not detect very well. The question mark around some of the results means that it misidentifies it or identifies it, but with a grain of salt. It gives some disclaimers that it's not sure, and etc., etc. And again, it also, there is lack of transparency, right? We're not sure exactly why, and if you rerun the same prompt, you'll get slightly different result. So it's hard to control, but the point of this slide is that it is far from being a solved problem. Even with the most advanced models, even when you have the humans specifically employed to detect all these things, if the context is missing and the social context is missing and sometimes some cultural knowledge and context, it would never really detect the hate speech. So just two architectures. This is from the one on the left, is from an earlier work on hate speech detection on Twitter, the ECHO data set. I don't know if some of you may know it. So this is a very, I would say, preliminary form of multimodal training. Okay, it's a naive way. But we do combine the text and the social networks, and we append the different vectors of different types of features and embeddings and everything, and eventually feed everything to any classifier, which would be a classification model here. It could be a logistic regression or MLP or whatever, it could be BERT. And so we show that improved results are improved when you account for the social structure. And for the text of the peers and all of it. This is, again, this is not surprising, but what is surprising a bit is that there are differences in the ways you treat followers and followees and different to different extent. The architecture on the right here, which we use for stance detection, and we also use it for playing with it for hate speech detection. So here we combine the textual embeddings, BERT style embeddings of the sentence, and structural embeddings like the ones from the other paper that looks at the conversation as a graph. And we combine this representation through a GRN. A GRN is a form of layer that gets different types of input and refers to it explicitly the way it was designed. It comes from image processing. It refers to one type of input as the main primary input and the other type as the contextual input. And again, it's the basic representations are very simple. Are learned independently by pre-trained models, but then when you use it with the GRN, you don't just combine the representations and feed it to a new classifier. You train the whole system backwards. Okay, so and it works really well, and we find that it works well on an array of problems that are slightly different. And now I'm going to have some 20 minutes or so. I'm going to talk about the Reddit, which is the Reddit experiment, the R-place, which is, again, the idea is to show how accounting for the context, the social context matter here. The setting is, again, is very different from the other settings of just identifying hate speech or hate communities. But I think it's really cool. The data set is really cool. I like talking about it. The results are also good, but I think the data set is much, much cooler than the results. So who knows, who is familiar with R-place? So just very, very few. Okay, even though it happened 3 times, I think, by now. It was actually last summer, if you remember, there was a big rebellion against Reddit because they blocked the API. So they restarted R-place in order to attract people back. That's how successful it was. So I'll explain what R-place is. So in April Fool's 2017, so every big company is doing some kind of a joke, experiment, whatever that is. Okay, so Reddit with no exception. So suddenly on April Fool's, there was a new subreddit that appeared. It's called the R-place. No one knows exactly what's going on there. And the subreddit had a canvas, a shared canvas of 1,000,000 pixels, 1,000 by 1,000 pixels. And apparently people could choose a pixel and change the color of the pixel to one of 16 predefined colors. And it's a shared canvas, so everyone basically sees a change in the canvas. But there are no rules and no objective, no nothing. There is one caveat is that once you change the pixel, you can basically change as many pixels as you want. But once you change the pixel, you're blocked from the system for some random amount of time, between 5 or 3 to 20 minutes. So you can't just do like, in mind thingy in Windows, just change many pixels. Obviously, people could overwrite your pixels, or you could overwrite your own pixel after when your timeout expires. This experiment ended after 72 hours, but again, no one knew that in advance. Okay. And the other catch was that you could not create a Reddit account in order to participate. If you already had an account when it started, you could change pixels, but you can start and create a new account and participate. So here is the canvas after some time. Okay. And now I'll ask the people who are not familiar with R-place, what's going to be, again, we now know 72 hours. So what's going to be the state of the canvas after 72 hours? So here are the options, mostly white, mostly black, some beautiful image, white noise, something else. Any ideas, guesses? No guesses?
It's tough when you know that you're likely to be proven wrong in 5 seconds. And I remember now.
I'll not prove it. So you remember that, but then I just presented the data set, and there are so many things, and we have great results on that, about that later. So some brave, courageous person. Okay, so here is the final state. Okay, so this is amazing. And when I first heard about it, okay, so I heard about it. I read like a long piece in the New Yorker about Reddit and how toxic Reddit is. It was like this very long pieces, and like the final last paragraph was, but maybe there is some hope because look, there was this experiment, and look how beautiful it is, and maybe there is some hope for the internet. Okay, and I remember getting to my office and checking a bit about that, and saying, this is not such a great thing. This is actually, it's not some form of beautiful collage and collaboration and artwork. This is actually the result of a war, right? Of a war on real estate between many competing groups. And we could use it to understand what's going on. How did this come to be, this beautiful collage, or this, the borders after some great war? And here are just some pieces of that. So this is, I'll go back for a second. So what you're going to see in the next slide is this area, okay, just a small area of the canvas. So here it is in one point, you see the French flag, you see the German flag, you see the French flag, you see the German flag, kind of history repeating itself, something else that you could maybe learn from it. But unlike history, France is fighting back here. That's the pixelization here means that there is a war going on, right? And people are changing the pixels back and forth. And eventually, at some point, someone they decided to have the EU symbol in the middle, and everything is good. The other thing that you can see here, for example, in this area, that once like I would say the states, right, or the empire established and secured the borders, they could start building monuments, right? You can see this, right, with all the different symbols, the national, national symbols and stuff, which I find amazing, and this happens within 72 hours, and it was nothing planned in advance. So how did this work? So here is a very quick tour of the 72 hours. And you could see a few interesting things here. You see this blue thing, which is it's called the blue corner. It's a group that wanted to make the whole thing blue. And you see the black thing here, which is another group that is called the black void, that was trying to ruin everything and make the whole thing black. And you will see that they're being attacked and attacking back. At some point, the blue corner announced that they would be retreating and letting everyone use their area. So we just kept the piece here, you see the blue corner, and that's it. It didn't work the same way with the black void. You see that they suddenly swarm and attack other areas. So this is very visual, right? And this is what people see. But again, this is 72 hours are condensed into minutes. But obviously there's some form of coordination here, and we need to understand how and why and what are the mechanisms. So first of all, there is coordination even here. Okay, here in the initial stages when it looks like white noise, it's not exactly white noise. It's kind of the distribution, right? Because again, I'm not a psychologist, but if I try to propose a psychological theory for that, so people tend to change pixels where there are pixels that were already changed. So that's why we see these clusters. Okay, so in this case, the coordination is just by the visuals. Okay, user log on, look at the canvas, see where there are pixels, and they add or change the pixel in different areas. But this is nothing fancy. Okay. Now, at some point, people realize that it's Reddit. Reddit is a forum system, so we could coordinate. We could really coordinate, and if we could really coordinate, we could do stuff. And here comes my interest in that, because suddenly we have the coordination, we have the language, we have the communities of the different forums, and they are, and now we have objectives of the different communities, and we could see how it works, right? And we could try and study and ask different questions about it. So first of all, the early coordination, it looked like, again, I don't know if you know what this means. I did not know myself. So excuse me for the next image. This is what, okay? And again, if you try to study the history of the internet, it's very, think about the 90s, right? Early 90s, this is what the internet basically looked like. Very white place, no rules, and very low quality visuals, right? Yeah, if you see here, the first message that was written in this board, can someone read that? Okay, so again, this is really funny, but again, if you look at the history of the internet, it makes sense. So here you have this 72 hours thing that no one knew what's, it's failed. It's like a kind of, external shock on the community, and you see how things evolve with time. Okay, but obviously after some time, you get much more sophisticated coordination, and here you get all the hate speech stuff, right? And the neo-Nazis, different trolls, and here the complaints that people like are deleting their swastikas, so let's do something else, and let's destroy the Russian flag, again, with some slurs, because their swastikas are being deleted. So this is another form of coordination. Again, Pepe, if you remember Pepe from the elections in 2016 and a bit before and a bit after. So again, it became a hate symbol of the alt-right. But forget the hate symbolism here for a second. You can see the really impressive coordination, right? So here is the Pepe. These are the dimensions. This is where we're going to do it. This is where we're going to put it. We expect it to take this much time. And when it's done, we're going to announce the next, where to put the next Pepe. Okay, but this is not, there are no hierarchy, right? Some random user and some random community decided to arrange a coordination. The coordinations were much more interesting, not only in like doing stuff, including symbols, also protecting symbols. So here is one that I really like because it's cute. There's a peace process here between Turkey and Greece. And the guy said that we really need some help because vandalism strikes us bad, and I have midterm tomorrow. So I kind of imagine him like spending like 24 hours, like doing pixels, like eating his cold pizza and really getting upset that their flag is being destroyed. Okay. But it's not only that. If you look at Sweden, that eventually had a very big flag, we fought bravely, but the Swedish night is rapidly closing in. I don't know if that's figurative speaking, or just because what happens on the canvas. And we need warriors. We have respected your boundaries, and etc. etc. And then essentially, at some point, they decided to do something which is called the flag, the flag alliance, which is sort of the UN that divides the board between states, right? Some of the symbols, or most of the symbols are not states, but there were a couple of dozens of states, and they decided to protect each other's border, etc., etc. And there were negotiations who is recognized as a state, etc. So if you want to learn also political science from online communities, again, you have that. It reflects geopolitical issues. Here is the flag alliance, for example. But for us, what's interesting again is to see how this coordination is unfolding, and can we predict, first of all, which community is going to participate. There are about 1,000 communities participating, but there are millions of about million, most of them non-active communities on Reddit. So obviously, if a community is not active in general or very small, it's easy to predict that they will not participate. So we kind of created a kind of a pool of communities that are at least on the shallow, on the surface, they are kind of twin communities. They have very similar shallow characteristics, and some of them participated in that, and some of them didn't participate in that. So the first paper is about understanding or predicting, and again, using both the language, the text, the norms of the community, and the community structure that is reflected by, again, if you look at the 6 months before our place, right? We didn't use the coordination or the text within these 72 hours. What we did is, okay, let's look at the text of the forum, the subreddits in the month before the experiment. And if you train a proper algorithm that would essentially create a representation of the community, and again, representation that takes into account both the text and also the social structure, there are the social dynamics, which are the cultural norms of the communities. Let's see if these representations would be good enough to distinguish between these communities and predict which community is more willing to undertake this suddenly, again, external shock and participate in this type of war, campaign, whatever you want to call it. So this is the first war, the first work. And then the second work is, okay, we managed to predict which communities would participate and what are the unique characteristics in terms of the social and cultural norms and community structure and the way it's arranged. And now we wanted to, but this is kind of binary. The community participated or did not participate. Okay, but now you could ask another question: how well the community will be doing? Because the community could participate, but eventually disappear and not leave a mark after the 72-hour closing of this canvas, right? So these are these two works. The first one is from 2 years ago. The second one is going to be presented next week. And I'm going to talk about them really, really briefly, few slides just about the results. So yeah, I said that we looked at the data prior to this, again, ArcPlace experiment. This is how we build, like this describes the communities and what are the S plus, S minus, or the communities that participate and didn't participate in the sample we created. So it's sort of the same number with very similar characteristic here. And this is how it differs from the characteristics in the general community on Reddit. So again, just to justify that if you just randomly sample communities, it would be an easy task to predict. The randomly sampled community does not participate, and that's it. So these are communities that have the chance to participate. And we looked at 3 different types of features, again, that we use for combined representation: the language, the community meta, like number of subscribers, age, average posts, up, down, etc., and network structure, nodes, edges, clustering coefficients, etc. And again, this is very naive in a way. Okay, it's naive because the representation of the community structure is naive in this work. That's the first work. In the second work, which we predict the success level, we actually use more advanced methods, both for the multimodal way to combine the representations in the learning process, but also the network representation. We use the graph neural networks to represent the nodes and the graph structure, etc. So just some results. These are some of the architectures we tried. There are different models here. It is interesting to note that, again, in this 2 years ago, relatively naive approach for the multimodal learning, the best model was the gradient boosted trees, okay? And not, we didn't have LLMs like the generative LLMs back then, but we did use like the zero-shot BERT and the other manipulations of LSTMs and parallel LSTMs, etc. It was very, so first of all, you see that the results are really good. Like the F-score is 0.82. And obviously, best results are achieved when you combine all type of features in an ablation test. The reason we think why the gradient boosted trees perform the best is because the multimodal approach here is really naive, and decision trees are very good at dealing with different types of data, right? This is, even though they were never designed like as multimodal models, right? But they are taking very different types of features, right? So they date back to when people used to do feature engineering, and they performed well. And it also combines with the fact that in general, we have the sample is not so big, okay? So we have about 2,000, 2,500 like instances altogether, and each of them was very rich in terms of the social structure and the text. So, so the more sophisticated the models did not learn well, because again the data was a bit small. So these are our explanations or good explanations for why the GPT models perform best. This I'm going to skip that, and I'm going to move to the other paper, and I'm going to short. So in the next work, we'll try to also predict how well the communities would do, okay? And again, it could be defined as a binary task if they would eventually leave a mark, or if the community will completely disappear from the canvas, or we could try and define different success in different ways. So for example, we could talk about the number of pixels, right? But again, this is very naive because a large community is more likely to achieve like more, placement of more pixels. So we used a bunch of success metrics. The most basic one is the number of pixels in each of the symbols, but we also use the entropy right, of the symbol, because if the entropy is high, it means that it's harder to coordinate and to achieve that and to protect that. We use a diameter because the diameter is kind of approximate how long is your border that you have to protect against other groups. We also use the locations. Some locations are more, let's say, they're more coveted real estate, so they were attacked more. So in these locations, even if you have a smaller flag or symbol, right? Even if you have some smaller, lower entropy, it still may be harder than putting a larger symbol in somewhere else. So here are some examples. You see in the middle one, we have the different types of symbols. Here you could see the rangers that were here and were completely destroyed, and by Pakistan. Pakistan was destroyed by India and by Belgium. And here is in the last row, you could see a place where the real estate was really hot, okay, that it was attacked repeatedly by these black void trolls. So again, we take all of this into account and we build different classifiers, or we train different models according to predict success, but according to the different success measures. As I said, in this work, we used more principle of the multimodal approach, and the representation of the networks of the community was, again, more principle. We use graph neural networks for that. And we also tested not only the different types of success definitions and measures, we also checked if you could learn something from the change in the way the community interacts in the few months before the experiments and in the 72 hours within the experiments. Again, to see if there is a correlation. Obviously, there is a correlation there, but we also we were interested in the outliers to see, okay, which communities managed to make the shift, right? So there is some emergency situation here, and by if you look at the behavior, right, of the community before the emergency situation, you may not expect them to do so well, but then you see a switch in the time of crisis. And they do again well. All of this in the paper, so I would not talk about it now. I skip it because I think I'm over time. So again, you could define by entropy, by size, by this everything is in the paper. And again, just to show you that there is a correlation between the different metrics, but there are some communities that are kind of outliers, and these are the interesting one. So here you have the number of pixels on the y-axis, the community size on the x-axis. The color indicates the entropy, and the size indicates how contested the area was. And you see that there's some, the League of Legends, for example, and the Oshu is this pink circle that was repeatedly attacked at the bottom. You can see that they are above the line here. I'm going to skip all of that and just final thoughts. So the first one, I'm preaching to the choir. I think that context, social context matters, and it helps. LLMs usually do not use it properly, and it's hard to learn it properly. But it's crucial in some tasks. It helps in many tasks, or maybe in most tasks, even it improves the results. And in terms of the methodology of how to actually do it properly, so we tried different ways. Some are more, I would call ad hoc, some more principled. They all work to some extent. We don't have the silver bullet yet of one architecture that is good for different types and sizes of communities and different tasks, etc., which is a good thing, right? Because different settings and social settings and tasks are different, so it makes sense that the representation and the learning, right, the training system would be a bit different. On the other hand, we always want to have some elegant solution that works, and we're not there yet. It's a bit of a bummer, I must say, but again, it gives us opportunity to a lot more research, and that's it, basically. But again, the data itself, the data set is amazing. Like, you do a lot of things and ask many questions that many of you I know are interested in. And suddenly you have the data in a sort of a controlled experiment, and naturally, it's not controlled, like naturally acquiring like experiment on large scale of how communities behave, clash, organize, etc. And again, you have the text.